Hello everyone. In the next 8 to 10 minutes, we are going to cover one of the highest yield statistics topics for MRCPsych paper B, measures of central tendency. And by the end of this session, you should not only know the definitions of the terms used in central tendency, but also understand how to choose the right measure in clinical research and also in exam scenarios. So let's now begin. Let's understand what is central tendency. Central tendency is the value which best represents the center of a data set. So when researchers collect data, whether it's depression scores, age of onset, or admission duration, they need one number which summarizes the center of the data. And this number is called the central tendency. So the three measures that you need to be aware of for MRCPsych paper B are mean, median, and mode. Mean means the arithmetic average, median is the middle value, and mode is the most common value. Like for example, we can look at this data 8, 10, 12, 14, and 16. Try figuring out the mean, median, and mode according to what you understand. And in the further of the session, I will take you through how exactly we work out mean, median, and mode. So let's see what is mean. To calculate it, we add all the observations and divide. So as I said, mean is the arithmetic average, and to calculate it, we add all the observations and divide it by the number of observations. So like for example, we have this data 10, 12, 14, 16, and 18. Now, when we need to calculate the mean, we need to take the sum of all these observations. 10 plus 12 plus 14 plus 16 plus 18, and the sum is 70. And then we divide it by the number of observations. And the number of observations here is 5. So 70 divided by 5 is 14. And that is the mean of this data. The mean is statistically powerful because it uses every value in the data set. However, it is significantly affected by outliers, and that is its limitation. So let's understand what is the effect of outliers. Look at this example. 10, 12, 14, 16, 18, which was our original data, and we got the mean as 14. Now let's add an outlier. So instead of 18, we are adding an outlier, which is 100. A single outlier increases the mean dramatically. So it has increased from 14 to 30.4. So now the question is, if we look at this data, does 30.4 represent the group? Obviously no, isn't it? So this is why the mean may be misleading in skewed psychiatric data sets. For example, the length of hospital admission, which is highly likely to be a skewed data. So now let's see how a median differs from mean. Median is just the middle value after arranging the data in order. So any data that you have, you need to arrange that in an ascending order and look at the middle value that becomes your median. So in this example, we have 3, 5, 7, 9, and 11. So we have got 5 observations. 5 is an odd number. So in that case, things are easier when you have odd number of observations. You just arrange them in an ascending order. Look at the middle value, that is 7, which is your median. Now the thing changes a bit when you have even number of observations. So when you arrange, now we have 4 observations here, which is an even number. So we have 2, 4, 6, and 8. So if we look at the middle number, we don't have a middle number. We instead have two numbers in the middle, that is 4 and 6. So in this case, the median will become the sum of 4 and 6 divided by 2. It is given by the formula xn by 2 plus xn by 2 plus 1. So xn by 2, in this case, n is the total number of observations. So xn by 2 becomes the second observation and xn by 2 plus 1 becomes the third observation. So the second and the third observation, that is 4 plus 6 divided by 2. That becomes 5. So 5 will be the median in this case. Now, unlike the mean, the median is not pulled by the extreme values. So it is resistant to the outliers, and that makes median extremely valuable, useful when the data is skewed. Now let's see, what is a mode? So the mode is the value which occurs most frequently. It is the simplest measure, but it is often overlooked. So mode is especially useful when we are dealing with categories rather than numbers, such as the most common psychiatric diagnosis. So we are dealing with the categories rather than the numbers. So for example, if we have a data set of 2, 3, 3, 4, 5, so the most frequently occurring value is 3, and that becomes your mode. Now the a data set can be unimodal, it can be bimodal, it can have no mode as well. So if in this data set, this has only one mode, that is 3. So that's why this data set is unimodal. Now for example, I'm going to add one more 4 here. So we have 2 3s and 2 4s. So in that case, the data will have 2 modes, 3 and 4. So the data set becomes bimodal. Now in this case, if I'm going to remove this 3, so the data becomes 2, 3, 4, 5. So in that case, does the data have a mode? No, it does not have a mode. So as we said, it is useful for categorical data, like for example, the most common diagnosis or the most prescribed medication, where we need to know what is the most common thing here. So rather than we are not worried about the numbers. Now, let's see how to choose the right measure. It is a very common exam question which asks which measure is most appropriate in this situation. Now, you need to look at certain things in order to determine that. If the data are symmetrical and it is normally distributed, use the mean. Like for example, IQ scores. They have a symmetrical distribution. They are normally distributed. So ideal would be mean. Now, if the data appears skewed, like for example, the admission duration, where we are coming across outliers, so go for median, that is the middle value. And if the variable is categorical, so if the data is categorical, like it is the diagnosis frequency or the commonly prescribed medication frequencies, so in that case, the preferred measure would be mode. Now let's understand a bit about the skewed distributions. This is again a classic biostatistics exam concept. What you need to remember is the mean gets pulled in the direction of the tail. The mean is dragged towards the tail. It follows the tail. So look at what is positively skewed data and negatively skewed data. Now, the positively skewed data will be something like this, where you have a long tail on the right side. Long tail on the right side means the data is positively skewed. When you have a long tail on the left side, the data is negatively skewed. So, and remember, the mean is pulled towards the direction of the tail. So your mean will be here. Obviously, your median will be in the middle, and then comes the mode. The same thing applies here on the negative skewed data. The mean is pulled towards the tail, then comes the median, which is always in the middle, and mode comes after that. So this is again a common exam concept. So remember, in a positively skewed data, the order of averages is Mode is less than median, less than mean. While in negatively skewed data, the order of averages is mean less than median less than mode. Now, examples for positively skewed data: length of hospital stay, income, reaction time. These are all classical examples for positively skewed data. At the same time, negatively skewed data: age at onset of a rare disease. So the age at onset of a rare disease will be somewhere towards here, isn't it? That is what is making the peak. And the scores with a ceiling effect. So these are examples. So just remember, mean gets pulled in the direction of the tail, median stays in the middle, and of course the mode is the next one. Now let's do a bit of practice and learn how to apply this. So you have a question, one patient state, 120 days. So we have a data 4, 5, 6, 7, and one of these patients state for 120 days. So tell me which measure best represents the central tendency. There is an outlier. Mean we have excluded. Mean is heavily affected by the presence of outliers, so it's not mean. So what are we looking for? We don't have a mode here as well. It is not a categorical data. So we are going for and central tendency. So central tendency, obviously it is not standard deviation. It is not a measure of central tendency. So the answer is median. So go for median when you have a central tendency measure with an outlier. So let's have some take-home messages. Always remember, mean uses all data. It is sensitive to outliers. Median is the middle value, but it is heavily used, very useful in skewed data. Mode is the most common value, and it is useful for categorical data. For the exam purpose, this mnemonic can help you. Mean gets pulled, median stays in the middle, and mode repeats. So hope this was useful for you. If you would like to have further videos on MRCPsych Paper B stats or anything related to MRCPsych, don't forget to subscribe to the channel, and I'll see you in the next video. Bye-bye.